Good morning. Welcome to Dreamforce. My name is Alexei. I'm a principal architect with the Salesforce Platform division. I am primarily focusing on the integration capabilities of the platform. And this is a developer session in which I will be definitely making some forward-looking statements. So I'd like to ask you, please make your purchasing decisions based on generally available functionality. But don't hesitate to get excited about the new stuff we're building for you. Oh, is it? Oh, I'm sorry, it's not on the slide. I'll have to read it again. All right, the plan for today is I would like to walk you through some data integration options that are available within the platform today, and would like to introduce change data capture, which kind of adds to that choice for you. And I'll have to take a quick detour into Salesforce Event Bus because this is something that supports the change data capture functionality. It's an important part of it. And there's a demo, of course. After the demo, we'll take a look at the replication protocol of change data capture. There are some interesting details there that I'd like to discuss with you. And we will wrap up with a summary. If you could please hold your questions to the end. I'm sure we'll have some time left. And if there is not much time, I'll stick around here and you can ask me questions later. The integration options with the Salesforce platform, and I'm focusing on data integration options only. And the most well understood and well supported option is moving data in and out. It's supported by a well-established ecosystem of tools called Extract, Transform, Load tools, ETL. The ETL toolkit is very mature, and this is one of the big advantages of this approach. Another advantage is that once the data is moved, either into Salesforce or into your back office, it is local. So it's available for all the query and processing capabilities available within that environment. The relative disadvantage is that the data, as it moves, becomes stale very quickly, especially true for data sets that change often, that change rapidly. And you can address that by increasing the frequency of your synchronization, but really that puts a toll on the resources, so there is really no good point. It's a very difficult trade-off. An interesting alternative that we offer in the platform is data by reference, virtualized data, external objects. Works really well for large data sets that you don't need to address at once. When you need to address them in a very narrow context, for example, if you have a point of sale database of a big retailer, but you need to pull last 10 purchases for a specific customer. This is perfect for virtualized data. You get the query, your data is always 100% up to date, and you can put it in the context of a user interaction immediately. You don't have to worry about synchronization delay or anything, but the disadvantage is that there's latency on the path to the data, and also you are limited in the ways how you can process the data. For example, different joint scenarios may not work well, reporting doesn't work that well, so the challenges become when you need to look at the data set in its entirety. And the new trend in the platform is event-driven integration. This is where we change the conversation from data-centric view of the world towards business process-oriented view of the world. And it really works well for the large-scale systems where you have different services evolving on a different pace, connecting to the system at any given time, and having different uptime characteristics. So the larger you go, the more advantageous it is to think about your application, your enterprise in an asynchronous way. But it's a different way of thinking. So development teams need retraining. Development teams need different way of approaching the problem and designing their systems. So that's a challenge. What change data capture adds to the mix is a bridge between data set-oriented way of thinking about your applications and event-centric view of the world. Change data capture offers a stream of changes out of Salesforce. Each of the events in the stream represent a change to the data object. So you can update your data sets in real time. It kind of sidesteps the difficult trade-off of synchronization. It improves on what ETL tools can do for you by allowing to track changes and apply them to your external data set immediately as they occur. But also it allows you this smooth transition from data-centric architecture to event-driven architecture, where instead of viewing change events as updates to the rows in your database, you view them as business events. For example, if you have an account created event, you can interpret that as a new row in your account table on Heroku, in Postgres, or you could think about that as about new customers created, and you can have a business process arranged around that. Change data capture uses Salesforce Event Bus as its distribution medium, so I'll have to talk about that a little bit. Salesforce Platform now supports event-driven applications in general. Platform events is where you can define your own events, you can define schema, much in the same way as with custom objects. Once you define platform events, they travel across topics that offer durable subscriptions. So this is a pretty unique feature of the event bus. You can have durability and you have pub/sub, and you can mix the two together. And we have some stream processing capabilities on the platform, and you can subscribe to events of the platform as well. Events are always strongly typed. Platform events are types you define. Change data capture events are the ones that we produce for you based on the relational entities. It's time for the demo. So in my demo, I would like to talk a little bit about what's inside there, because I don't have a flashy UI. But really, I have a Salesforce org where I focus on the account and a custom payment object. There's a relationship between them. I have change data capture activated in that org, so it produces my stream of change events that I subscribe to from my Heroku application. Heroku subscriber uses EMP connector, the standard way of getting into the streams of events on Salesforce Platform. And it has a Postgres database where I have an account and payment tables. So the goal of this is really simple. I want to replicate account and payment changes into my tables on Heroku Postgres. So let's see it in action. So here I have my Salesforce org on the left. My Heroku app really doesn't have any UI. So these two windows are basically our monitoring pages. They're served out of that application, but here we see a list of events as they're received by the subscriber. And here we see the state of the database. Of course, both are pristine now. We don't have anything. My database is empty. So let's go ahead and create a new account. Now CDC captures that change and propagates it to the stream, and we can see that my subscriber can see the event, and it applies it to the database. In the database, I have an account entry widgets Inc. now. And we can log some payments for this guy. So I have a create payment event in the stream, and that payment appears in the database. So now I have two tables populated by the CDC stream. Well, let's do one more. And we can create another new account. Well, now we have two accounts. We have some payments. We can put another payment in here. So my business keeps going. We keep entering accounts and payments. But what happens if my subscriber fails? Well, Heroku is very reliable. It never fails. It never crashes. So I'll have to simulate a failure by shutting down my dyno. So basically, I turn everything off and confirm. And now my application on Heroku has nothing. It's not running. It's in a failure mode. Yet my business doesn't stop. So if I refresh here, you can see. Oh, did I shut it down? Hold on. Let's confirm that it's really down. So let's take note of that number here. So as I mentioned, we are an offset-based pub/sub. So that number here is an offset into the stream, and I'll get back to what it is really. But business keeps going, so I enter new payments. And while my application is still down, we get new rows into the database that appear on the stream. As we re-enable the application, or as we fix the application if it was a real failure, and restart. So now I see the stream from 158. If you remember, we had 157 there. So my application resumes from the position of the stream where it left off, gets the next event, and puts it in my database. So let's switch back to my slides and see what's really going on there. As I mentioned, we use the time-ordered event log as the underlying storage paradigm. So essentially, we write all events to disk and assign an offset to them. We assign a sliding window that provides you the recovery time. In this case, the sliding window is 24-hour long. So as long as my Heroku client or your application that performs replication based on the CDC stream comes back within 24 hours and supplies the replay ID of the last event it saw, it will be able to recover and catch up with the tip. This paradigm is popularized by Apache Kafka. So if you're familiar with Kafka, this is the exactly same storage paradigms, exactly same data structure that we use here. Actually, I have 3-day replay window. I said 24 hours, so we're striving to increase that. The interesting thing about this is that we can have multiple subscribers, any number of subscribers, and they can consume their stream at their own pace. As long as they remember their own replay ID and have storage for that, they don't have to go in sync. One of them being slow does not delay others. One little detail that is very, very important. As you store the replay ID, you need to pick where and when to store it. For example, if I save my replay ID to disk and then process my changes, I'm opening myself up to a failure in between that could leave my replay ID advance to the next position, yet my changes not applied to my database. This is called at most once. It's a valid strategy in some cases. In my case, where I'm dealing with replication, it's probably not ideal. I'm not very happy with this one. If I process my changes first and then write replay ID to disk, it's better. I have a different challenge though, because I can process my change and fail before I have a chance to update replay ID. In this case, I may see the same change again when I restart and recover with the replay ID as saved. I have to be prepared to detect and handle duplicates. Essentially, my processing has to be idempotent for this. Fortunately, we're on Heroku, we're in Postgres, and it's a transactional database. I really took advantage of that in my demo. I put the replay ID into a table in the database. I put it within the same transaction as the changes that result from my processing of the change. So what happens, we open a transaction, we process our event, we update the replay ID, and we commit the transaction. So it either goes in together or doesn't go in at all. If there's a failure, the entire thing gets rolled back, my changes are not there, and my replay ID is at the previous position. If the transaction is successfully committed, I'm guaranteed to restart from that point on, no matter what happens to my dyno, Heroku in general, or the network in between Heroku and Salesforce. Well, now that we've covered the reliability, let me take a quick detour into more boring stuff, but I think it's also pretty relevant. So the replication protocol of CDC is based around the notion of change event, which is derived from the parent relational entity in the sense that it inherits all the attributes. But there's an important component there that we add on top. The change event header is an extra field in the event that describes how that change fits into the overall stream of transactions as they're coming out of the system. So there we have a transaction ID, so you can group changes that went atomically into Salesforce. You can group them together on your receiving end and apply them atomically to your database. It also has a sequence number that is an order of that change within a transaction. So you can always apply it consistently in the correct order and resolve all the referential integrity there. We also have a change type. It's update, create, delete. You can tell what's going on. There are a couple of other things that allow you to prevent loops, that allow you to find the timestamp of the change. So it tells a lot about the event itself. In the payload part, we have all the fields available, but we only ship fields that change. So we really are about deltas. We don't resend the entire record for you in the name of saving space. And another important thing is we are aiming at both data replication and business process integration use cases. So even if you have two consecutive changes that logically cancel each other, for example, you have an update and a subsequent delete of a record, it wouldn't make sense if you just were looking at replication. It wouldn't make sense to send the update because you have a delete within the same transaction. We emit both because sometimes for the business it's really important to see that there was an update, even if it was followed by the delete. So CDC is both a business event stream and a data replication stream. So let me summarize real quick what we covered today. CDC offers you a durable stream of changes coming out of Salesforce. The stream of changes includes only deltas, not the entire records. But it also gives you transaction boundaries and very strict ordering of the transactions as they're applied to the Salesforce database. The stream is expressed in strong schema that is derived from the S object. Change events are S objects themselves. On the stream, we also offer you an Apache Avro schema, so you can see how the schema of the event evolves over time, and you can handle resolution between different versions of the schema. We aim for the data replication use cases and business process integration use cases. And in fact, I think one of the big advantages here is that CDC offers you a smooth transition from one to another. And the most important point here is that we are in pilot. This is new. This is not generally available, but you guys can sign up for a pilot. All you need for that is to reach out to Jay Hurst, who is the product manager for Change Data Capture, or reach out to me. Ping me and I'll hook you up with Jay. I put some links to some code snippets and some documentation that is relevant to this presentation. I'll share the presentation slides later with you. But that's about it. Thank you so much. And if you have any questions, I think we have 2.5 minutes. Yes, please. Say again?
Once it goes live, is it going to be part of the platform, or is it going to be a separate license?
Once it goes live, it's going to be licensed separately, and it's going to be an add-on feature. Yes, please.
Is it going to support all field types, like long text, rich text, in the fields that are spent in the package?
Yeah, so the question is the field types coverage. It's going to support all field types. We do some optimizations with regards to long text field types, because sometimes it's not economical to ship them entirely. So we have a diff format, so you may get, within a delta event, you will get a delta to that long text area, but you will get the updates to those.
Is this different from subscribing to platform events using a common protocol and updating our own database?
Yes, so the question is the subscription method, and it shares the same subscription method with the platform events. You use Comet D protocol, you subscribe to an event that is called account change event, or you can subscribe to all change events coming out of the org. But the protocol is the same. EMP connector, the open source project that we have out there, is still applicable. The question is about the timing of the general availability, and it's a really good question, and unfortunately I don't have an answer. We are still going through the pilot program. We're collecting feedback. The feature is pretty heavy in terms of resource utilization, so we want to be sure that it's ready for you. Hopefully around maybe next year, next Dreamforce, we can give you the exact timeline, or maybe the license already. The question is about the number of events that can be consumed. With CDC, unlike platform events, we don't monetize the number of events because you don't control that, right? You don't produce the events that are coming out of our system. So we have limits for the service protection, but in terms of licensing, it's still shaking up, but in terms of licensing, you should not be constrained. Yes, so yeah, typically what the question is about the relationship of platform event limits versus CDC limits. when we deal with service protection, the limits are really, really high. If you hit them, most likely you're doing something wrong, really. So then we need to talk and figure out what your use case is. Yeah. I'm out of time. Thank you so much. I'll stick around if you have more questions. Thank you.